The Salin and Simonban book introduces the idea of feedback loops. So we have positive feedback loops and negative feedback loops, or reinforcing loops, things that really escalate, and things that balance each other out. So an example of the world population, because there's more people on the world, they can make more things, better medicine, etc., more food, and that means that their world population will grow in turn, and that will mean that there are more people. So this is sort of a escalating, spiraling, out of control kind of balance. Well, if you simplify it, and of course there are things to say about such an example. Then the negative feedback loop will be a thing like a food web, or a prey-predator system. So, for instance, if there are more bunnies, then it's likely to have to introduce a growth of the number of hawks that are out there. And by introducing if there are more hawks, then actually the number of bunnies will go down again. And that means that the number of hawks will also go down again. So you sort of get a balancing loop in nature there as well. And in the book, they will use the example of a thermostat. So the temperature is automatically sensed, and then it will keep at a constant rate. So, like I said, the thermostat example is what's given in the book. But we can also come up with our own weird kind of feedback loop, negative feedback loop. So in this case, I came with the idea of a number of prey and predator. So you can imagine that if the prey's location is within the reach of the big bad wolf over here, then the wolf will eat the sheep, which is then the actuator or what's happening, which would mean that the wolf population is going up. But that means that the number of prey will go down, and in turn, less wolf will be able to eat the sheep. So basically, it goes towards an equilibrium. The other way around, we can also think of a positive feedback loop in the same kind of occasion, where we could say, well, the sensor is the movement. We have a number of friendly-looking sheep, which are then maybe moving a lot, because the big bad wolf is in the neighborhood. That might mean that they are running a lot, and if the running comes towards a certain threshold, they might be coming into panic, and that sort of escalates. In that sense, you can see that as a positive feedback loop. Or from another book, we can play a game of basketball or shooting hoops, where as a positive example, we could say if you score a ball, then the next turn you get a free turn, so you can try again. Whereas when it's in the negative loop, you could say, well, you have to skip a turn. For instance, if you would do a best out of 5 or something like that. Mario Kart has a lot of these negative and positive feedback, a lot of negative feedback loops actually. So the sensor is mostly of those loops the position in the game. We could compare that to the others. So we could say, well, I'm ahead, I'm the first player, or I'm in the middle, or I'm behind someone. And depending on that, you can get the power-ups. So you can collect power-ups during the game. And these power-ups can be more or less valuable. So the blue shield is pretty well known, where you the first person, I think, gets the blue shield on top of his head, and then he slows down as being the first, whereas the person behind will often get a speed up kind of power up. What also happens underwater in those kind of family kind of race games is rubber banding, where the competitor's speed will go down or up depending on how well you're doing it. And as like I said, it's more fitting for such a family kind of game, but sometimes it also happens in arcade games, which takes a bit away from the reality that it is, which a lot of players, of course, then don't like. So that's why it's called rubber band, because the first player is as a virtual connected to the second player, the second player to the third, etc., which slows down the first one and speeds up the other one a bit. Then Age of Empires is this game where you are playing with a civilization, where you have to collect and gather food and wood and these kinds of things. And then you can build buildings, and these buildings you can build new people who fight, or you can build new collectors. And this goes on and on. So if you build more of those gatherers, you get more money. With that more money, you can build more villagers, which gather more food, which increases the number of gatherers that you can get. In the same kind of way, you can also have a loop with the territory. So you can imagine that once you are starting at a village and you start exploring, you have this thing called fog of war, so you don't see the entire map yet. So this will be black most often, and this is your base. You will go there. And then you might encounter this settlement. And if you encounter this settlement, you can build a trading post on top of it, which means that you will get certain skills or unlock something. In this case, it's a native sentiment, maybe, where you can then get more powerful units, which means that you can go again and gather more territory. So that's also a positive feedback loop, but now with territory instead of money or food gatherers as a sensor. And this also happens for the game, the tech, the research upgrades, etc. Then between the positive and negative, besides the positive and negative feedback loops, where you can clearly see a sensor, comparator, and activator, there's this thing that they call pseudo-cybernetic feedback loops, which basically keep static, and the rules are always the same. So the game of Goose, at the end there is more, and this is, and letters, where you have to go from one place to another, but at the end there are more of those snakes and letters, snakes, which will make you go back. So close to the end, it's always a bit more frustrating maybe if you are ahead, because the chances of you dropping back increase, which makes it a more tight game at the end in that sense. This is not the same as it basically happens at the other thing, because it doesn't depend on how you do it. It doesn't depend on the thing that you are measuring, but it's just basic rule. However, if you would change certain things, you could maybe also see it as a normal feedback loop. And then another part that they call in the book is second order cybernetics, where you also take into account the observer, or perhaps where you take into account the dynamics between the players, like we explained last time with the mechanics and dynamics, which is related to it, is that you might set a certain set of rules, but then how the players play around with this might be involved, but how people interact with each other. So you can have something called a sort of social feedback loops, where people might be doing performances, where they might want to show off. And in that sense, they also create a feedback loop, because if they are ahead a lot, they will do more of these performances, more of this showing off, which makes their performance not so good, which introduces a sort of negative feedback loop. Negative feedback loop. So they stabilize the game. The positive feedback loops, they destabilize the game. Negative feedback loops prolong, make a game longer. And positive feedback loops can end it. So it's also a very good thing to look at once your game is too long or too short. Can we introduce a positive or negative feedback loop? Positive feedback loops often magnify the early successes, whereas negative feedback loops magnify the late ones. Feedback systems can emerge from your game system by accident, and it's often just the case that you have to identify them by a lot of playtesting and really analyzing what's going on. And Monopoly is one of those examples that we'll touch upon later on, where it's a sort of a hidden feedback loop which prolongs the game. And feedback systems can take away the control from players. For instance, that rubber banding, which will not be appreciated by a lot of players. So we looked at a few of those positive feedback loops in Age of Empires. Positive feedback loops, yeah. We could also see the resource depletion as a negative feedback loop, where you have to gather things, but if there's nothing left to gather, then you don't get money anymore. Well, in that game, actually, it's a bit different, it is a form of negative feedback loop, because at some point you have to go over to less efficient kinds of gathering money. What we see over here is a specific kind of dynamic difficulty adjustment, because it's procedurally generated. It's procedurally generated content, or procedurally content generation, combined with dynamic difficulty adjustments. So you can imagine that once you jump over here, as being Mario, that you might drop that a few times, which makes the thing that, well, maybe we should make the game a bit more easier. So you can come up with the idea of adding a bit of content here. So it makes it easier to jump first over this one and then jump to this one, so the game becomes easier. But you can also respond to other things and maybe add things based on interest or gameplay as well. Anyway, especially if it's about difficulty and adjusting how people are performing inside the game, you can use this term of dynamic difficulty adjustment, whereas Shell uses a slightly different term, which is dynamic game balancing. But the above one is more well known if you would Google for things or want to have examples, etc. However, there is a big warning. So there's a lot of overestimation. So you can look at this quote. Extremely young game designers frequently speak of their desire to create a system that will adjust to the player's skill level on the fly. And this is a beautiful dream. So yes, it sounds nice, but often there's downsides which you have to take into account. Spoils the reality, it spoils the real performance of people. People might notice it, which makes it become exploitable. And when players improve by practice, they can overcome such a challenge. Actually, that might be one of the things they're looking for. So they feel dumbed down and insulted. So yes, I also played around with dynamic difficulty in the playground, for instance. So what you see over here is a tagger which has a red circle. You see 3 runners over here. When the circles touch, you tag someone with a virtual circle. If you are a tagger for a very long time, I made the circle grow, so they become easier to tag one of the runners. And the same thing happens for the runners. If they're not doing so well, then their circles become smaller. If they're doing very well, the circles become bigger. So it becomes easier or more difficult for the tagger to tag them. Also here in these experiments that we run with fellow students, quite some time ago already, we saw that people also exploited that. So they would notice that there was something going on with these circles becoming bigger or smaller based on their performance. They thought actually it was dependent on movement. So they just stood still for a bit and then used it. At other times, people did like it. So one of the situations that happened over here was someone had a knee injury, so she couldn't walk very fast. And then basically it could help a bit. But still, you have to remember that it's quite exploitable. And it doesn't work as easily and it doesn't work as perfect as you might imagine. Things that you actually want to balance is that it becomes choices which both make sense. So you don't want to have one that's really dominant over the other. But you want to offer these different kind of strategies to the people. So there's always kinds of things that you have to balance or stabilize these kinds of strategies and make it interesting trade-offs for the player to really consider. The same happens with civilizations. You can pick a lot of civilizations in the game. Same happens with units. You don't want that they just pick one unit which is more powerful, but you want them to have interesting combinations of them. And this goes berserk, especially if you look at Age of Empires 3, for instance. Then it's just the speed with which they are gathering. You can see that once they have to gather a tree, then there's actually a difference between what kind of unit for what kind of civilization happens, what kind of multiplier is there. So these are a lot of variables which have been tried out and set in order to balance these kinds of civilizations. I will come back to the Monopoly example later on, but this is one of those hidden kind of things, and this is one of the social influences. So basically people play the game with this additional rule of winning a lottery once you enter a certain square, where normally the fines go into a black hole. Now the fines go back into the game, and that makes that the game lasts way longer, because normally the money would go out of the game and now the money comes back in. So there's not really a good reason why the game would go towards an end. And that makes why playing a game of Monopoly suddenly can take up 3 hours instead of just the normal time that was supposed to be. In Settlers of Catan, you can also see different kind of social info. The Monopoly example is actually pretty well known. In Settlers of Catan, you can see that people might be sharing or buying or exchanging on a different rate based on how people are doing. So, of course, if someone is ahead, you might not want to give a good deal to him or her. Well, as if someone's back a bit, then you might give a fair price for something. Like I said, you can also see that happening in some sort of games. So once you are way better than another player, for instance in FIFA, then the player might start doing tricks. I don't know, running around with the goalie in order to score a goal, which is of course not the most efficient way to play the game. Or when you're playing a shooter, to only use headshots, so you only shoot once in order to get a kill. Or use very low-powered weapons like a knife instead of a gun, or something like that. So people use this kind of performances, showing off, doing little dances, etc., which are not intended to really be efficient in the game, but instead they're just a theatric kind of exposure of how good they are, of what they want to show off, of showing what they find interesting. People might also set additional goals, their own goals inside the games. So we play football or table soccer, you could say. And once you also win with 10-0, then there's an additional rule that you have to crawl under the table. So you have an additional rule. So even if the game is totally unbalanced, it also becomes interesting, because then it's still interesting at the end when one person scores 9-0 and it goes to 9-1 or it goes to 10-0. And at other points, we might introduce handicaps or we actually help each other actively. For instance, if young people play a game, then the young ones might often start, or some other help might be happening. And maybe you also see these kinds of things when you remember your pen and paper playtest session of how people would adapt social rules based on your rules that you came up with. So why do these feedback loops matter? Well, as we will see, there's a lot of balancing types mentioned by Shell. So a few of those are competition and cooperation. Of course, the game time and how long things take is essentially for the short versus long balancing type. And feedback loops are all about that. So it's a way to really look at these kinds of things in a different way as well, and really make a model or analyze these kinds of things. So I think it's very important also to understand how this feedback loop works and how to introduce or maybe remove something.